question looks lengthy. Let's try understanding first. Given to you is a function whose domain and range is both the intervals 0, comma 1. So roughly let's start drawing here. Let's say this is 0, 1. That's the domain and here you have a range. So your function will lie inside this box. And vaguely if I draw, this is the function given to you, the cubic equation. So if I vaguely draw, let's say this is my function f of x. Now next they are saying consider the square. Of course we have already drawn the square. The square they are calling S. Let G collection of all points in the square such that y is greater than f of x. What do you think? Which points are that? Y is greater than f of x. That means this is the points collection of all points they are calling G and saying that it is a green region. So we know what is my green region. And what is my red region? All points in the square such that y is lesser than f of x. That means everything below that. That's your red region. This is your red region. Next, they are defining LH. Okay, LH is horizontal line. Okay, what kind of horizontal line? XH. Okay, x is varying from 0 to 1. H is fixed. Okay, that means for example, if I take H to be 1/4, so this would be my L14, for example. Okay, this is a horizontal line, okay, whose y coordinate is 1/4. Now, which of the following statements are true? They are asking that there exists an H such that the area of the green region above. So let's say this is my LH. Okay, now they want area of the green region above this line and below this line to be equal. So does there exist an H? That's the question. Okay, similarly the other questions also. So what do we do? First, we try to see, right, how my function looks like inside this square box, and then we will try answering all these questions. So let's get to work. So this is your square box. Okay, now to know where you want to start your function with, let's try to find out what is f of 0. F of 0, that means you have to plug in x is equal to 0 here. You end up in getting 17 over 36. Of course it is less than 17 over 34, right, which is half. So this is less than half. So somewhere here, let's say you have that point. Okay, 17 over 36, somewhere here. Now where do you end your function? Of course you are going to find what is f of 1. If you try finding f of 1, you will end up in getting 13 over 36. Okay, 13 over 36 is greater than 9 over 36. Okay, it's slightly more than 1/4. Okay, so maybe you are landing somewhere here. Okay, over 36. Okay, you are starting from here, ending here. What happens in between? Get the critical points to know which point is max, which is min. So let's find the derivative. Very simple. 3x square, 3 gets cancelled. So x square minus 2x plus 5 over 9. That's your derivative. You want to equate your derivative to 0 to get the critical point. So let's solve that. So equation is minus 18x plus 5 is equal to 0. Very easy to factorize. You end up in getting 3x minus 5 and 3x minus 1. So what are the critical points? X is 5 over 3 and x is 1/3. So 5 over 3 is of course outside the interval, somewhere here 5 over 3. So what about the sign of the derivative? Let's check. Okay, 1/3 and 5/3. Okay, so using your wavy curve method, if you are more than everyone, you are positive, negative and positive. That means your function is increasing till here, decreasing, and then again increasing. What does that mean? 1/3 you have maxima, right? Function was increasing and then started decreasing. So 1/3 you have function to have the maximum value, and you can quickly also find out what is f 1/3, which I have already done, and you end up in getting 181 upon 324. That is slightly more than half. Okay, this is slightly more than 0.5, around 0.56. So somewhere here maybe. Okay, so your function is looking like something like this now. Okay, so now also quickly draw what's your green region now. So this is your green region, and let's draw the red region as well. Also, they are talking about area. Can you find what is the area of the red region? Let's call the red region R. Okay, what is the area? Of course, area under the curve. You are just going to integrate the given function, f of x dx. Complete function. Solving this shouldn't be a problem. You end up in getting a half. So area of the red region is half. So what do you think area of the green region should be? The entire square area is 1, right? So area of the green region would be 1 minus half, that is half. Now let's start answering the questions as background work is done. Now there exists a edge such that area of the green region above that line is same as area of the green region below that line. What does that mean? So that means if I have this horizontal line, let's say here somewhere, so top area should be 1/4 and below area also should be 1/4, right? Now below area is little difficult. Let's try figuring what is the top area. How do I get the top area to be 1/4? Let's say this is your line LH. That means this y coordinate is h. What is area of this rectangle? Length is 1 and width is 1 minus h. So what do you want? 1 times 1 minus h, that rectangle area you want to be 1/4, right? So what is the h value you are getting then? 3/4. Okay, so if your h is 3/4, then of course you can do 1/4, 1/4, half half, green region you can divide. But alas, 3 by 4 is not here, right? So this is wrong. Okay, you cannot have h here. Now similar thing, they are asking for the red region. Can you have a line LH such that it divides the red region into half half? Okay, so let's say this is my line LH. Okay, that means this is the y coordinate h. This is my line LH. Now again, you want this below area to be 1/4 and top area to be 1/4. Let's work on the below area. Can I get the area to be 1/4? So what do I do? What's the area? This is 1 and this is h, right? So 1 times h, you want to be 1/4. Okay, so you want to have your h to be 1/4, which is quite true, right? Okay, and we already said that the minimum function value is more than 1/4. Okay, so of course you can have such an h such that you are getting a perfect rectangle over here. So yes, okay, 1/4 lie in this interval, so you can do so. B is correct. Now for the C part, let's draw a fresh. There exists an edge such that area of the green region above the line equals area of the red region below the line. Now, how do we think we can make this? First of all, let's have a logical sense here. That area below the curve was what? Half, right? We got here. The area below the curve is half. That means area of complete red region is half. Okay. Now, what else is half? If I divide the complete square into two equal parts, that means two rectangles, of course, I need to draw a horizontal line from half. This area is also half, right? Area of the complete rectangle is also half. What does that mean? That means the red portion you are getting rid of is same as area of this portion, this green and this green. Both the areas are same. Okay, so if from the red region you are getting rid of this chunk, okay, let's call that area to be, let's say, A. Even this green region area is A, right? Completely, like even including this one, both the area is A. So if from the red one you are reducing that much, even from the green one you are reducing that much. Okay, when your horizontal line is what? L half. Okay, that means C is true. Like when you draw the line L half, then whatever is the green region above is same as area of the red region below, right? So, and what is D part saying? D part is saying that area of the red region above the line. So that is what we have just now proved, that area of the region above is same as area of the green region below. So even D is true. So C and D are both true using just a simple logical sense. I will see you with another question soon. Bye bye.